Hi, everybody. I'm Vina, Senior Solutions Architect with the nonprofit group here at AWS. Thank you guys so much for coming. I'm going to be your guide through this session, and I'm joined today by two other incredible presenters who you're going to meet in just a minute. I just want to be totally frank with you. This title doesn't necessarily reflect the full content of the session, so you are going to be getting this, but you're going to get some bonus stuff in there too, so lucky you. All right. So we're going to structure this session in the form of three different stories. First, we're going to hear from Hanif from PBS. Then we're going to hear from Glenn at Stop Soldier Suicide. And lastly, I'm going to come in and show you how you can apply the learnings from these organizations to your own world and create a roadmap that feels reachable using these analytics and machine learning services. So first up, can we introduce Hanif to the stage?
Thanks, Vina. I'm Hanif Khalid. I am the Senior Director of Product Management at PBS. Let's see. So first, a little bit of background about PBS. So for over 50 years, PBS and our stations have served the American public with content that educates, informs, and inspires. We're different than commercial media. We're not a network. We're a nonprofit membership organization serving 330 member stations across the US. And our member stations reach 96% of the US population. So while our mission has stayed the same over the years, the media landscape has significantly changed. With our very important partnership with AWS, we're leveraging cloud and data as a big part and a key part of our digital transformation. I'm sure some of you checked out the keynote this morning where Werner gave a shout out to PBS, but AWS is helping us save cost when it comes to content distribution across our various platforms. We're also using PBS with AWS. We're also able to provide more personalized experiences to our audiences. I'm going to showcase some of that later on in my slides. So as we scaled our digital footprint from a broadcast to a multi-platform organization, we faced multiple challenges. While PBS is unique in a lot of ways, you'll see that some of our data problems are not. And I'm sure as I share some of those problems, they might resonate with what you might have seen in your organization. So why do we have a data problem? Well, first of all, we're collecting a tremendous amount of customer data, but all of that data is getting collected in siloed systems. And really, we have multiple sources of truth, which is creating this disjointed view of our audience. Second, when we first started using data, it was really for very specific purposes. So it was very much single purpose. And while there's nothing necessarily wrong with that approach, as new data teams wanted to use those same data sets, it just led to some inefficiencies and lack of reusability. And it's also really expensive for us to start new data projects because any teams that have a new data use case, they're mainly focused on bringing data together rather than solving an actual problem. And finally, just making data more retrievable and accessible was challenging because we lacked proper governance. So we've recognized that we have a problem, but where do we even begin? For us, we wanted a framework where we could measure where we are today and where we aspire to reach in the future. So we found a data maturity model, which some of you might be familiar with, that really resonated with our journey. So I'll go into the data maturity model, with stage one being manual data drudgery. So an example of this is sending an email to you with an Excel attachment to one of your executives. The problem is that the data set basically becomes irrelevant tomorrow because the data is dynamic and the data set's already changed. And really the risk here is that that same person is going to go back to that same data set and use it as their source of truth. The next stage in this journey, I apologize, there we go, is death by dashboards. So now you've gotten the Excel attachment and you've created a dashboard. But at this stage, everything starts becoming a dashboard. And when that happens, like there's multiple people managing these data sets, everything has a KPI. There are just too many sources of truth, and you really have no idea where to look at. So the next stage is when an organization is actually starting to become a little more sophisticated in their data journey. And this is really the only stage where data actually starts contracting for the first time. So you're taking a more controlled approach and starting to get a more consistent view of information across the organization. So moving from step 1 to step 3 is very doable, but it does take people, processes, and technologies to be aligned. On every organization's wish list is to get to step 4 and step 5, which is emerging intelligence and AI and ML is real. And really, that's, we've heard a lot of great things about AI, ML, Gen AI, but there's no silver bullet to get to this, and you really need to have a strong foundation in order to truly tap into true AI and ML workflows. I'll also be sharing some of the examples and prototypes where PBS is starting to leverage AI and ML in our data story. So once our data maturity strategy was established, we moved into execution mode, which was building a unified and governed data lakehouse. This is where we just started consolidating all our different data sources and to help us uncover new actionable insights. A key principle for us was that we wanted to democratize data for both our internal and external stakeholders being our stations. So rather than data being accessible just by a privileged few employees in our org, we wanted to have that data consumable across the entire organization. And we really feel ultimately that this lakehouse is going to improve our data maturity so we can start using data more as a strategic resource. So next, I'm just going to share a couple of examples of how the data lakehouse is already starting to benefit us. So starting with the PBS recommendation engine. So the PBS recommendation engine was a prototype that was built by our fantastic PBS innovation team using AWS services. So why did we even build this? We wanted to help our viewers discover more PBS programs. We wanted to create personalized experiences for our viewers, and we wanted to highlight the great station local content for their audiences. So PBS has millions of viewers watching thousands of videos every day. No human can review the viewing history of every individual and make recommendations to them. This is where we basically took our viewing information, we put it into Amazon Personalize to predict the best results. So since that prototype, we have now productized and released the recommendation across all PBS digital platforms. So I'm going to start with the Top Picks for You collection. So this Top Picks for You collection has generated over 130,000 interactions last month, and users are engaging with over 500 shows with this collection alone. So popular shows. This used to be a manually curated list. But now, since using the recommendation engine, this collection has seen a 158% increase in weekly engagement compared to the previously manually curated list. And finally, popular local shows. So KQED is one of our local stations. This is basically allowing us to highlight content enjoyed by the station's local audience within their demographic. Another example that I wanted to share with you all was that the innovation product team at PBS has also started experimenting with Gen AI, and where we've predominantly been looking at models from OpenAI to begin with. So we're exploring various use cases like writing in our brand voice, or creating call to actions for our PBS mobile apps. So what our innovation team has found is that this has been really helpful in creating metadata tags, descriptions or titles from things like our caption files. And we found that this can be a huge time saver for us. So now we want to actually really start operationalizing this. So we're going to be looking at AWS solutions like Bedrock to really integrate this into our infrastructure. So those are just two very specific examples. But overall, at a bird's eye view, the Lakehouse project, we truly feel is going to unlock immense potential across our entire system. So from a station standpoint, we'll be able to share more data for donor analysis and donor retention campaigns. For customers, as you already saw, we're starting to deliver more personalized experiences and personalized content, and their experience with PBS will only improve as we iterate and improve these products and these models. For PBS, we will also be able to get more efficient with the investments and the funds that we receive. And this is just going to make us a more data-driven organization. So to wrap up, I wanted to share kind of our top 3 lessons learned so far if you're just getting started with data strategy or thinking about setting up data infrastructure at your organization. So getting organizational commitment. So really here, building data maturity, building data architecture, it takes time. And setting the realistic expectations with your stakeholders is only going to serve you well, because you need that runway while that foundation is getting worked out. Having a clear why, so developing a data strategy that's aligned with your business objectives. Also, this is another place where you might want to ask yourself, do you actually have more than a single data use case? Because a data mart, especially if you have this one use case, a data mart might be all that you need. But if you know that the data is going to scale in the future and you're going to have other use cases, then it's absolutely worth investing into data lakehouse. And then finally, focusing on data quality, data governance, and data privacy. Data is what trains models, but privacy and governance dictates usage. So thank you, everyone, for your time. Thank you for joining us on this last session. But next, I'm going to pass it over to Glenn to share the Stop Soldier suicide story.
Good job, man. How's everyone doing today? I know it's the last session, so I'll try to wow you as best I can. So I'm about to talk to you. I'm the CTO and founder of the Black Box Project over at Stop Soldier Suicide. And what is the Black Box Project? It's using digital forensics to look at the last second, the last year of life of somebody that's committed suicide as a veteran or service member, and then using machine learning to identify those patterns and trends online. So who is Stop Soldier Suicide and what do we do? And so our main focus when we first started was to bring service members and veterans in crisis and have a call center for them to call in and make sure they get the resources they need and then go through a clinical process so we can make sure that they're getting the help that they need. We've served over 1,400 clients. We have over 1,700 hours provided care to them. 23% increase year over year. And it's sad to say that's needed. And we've had, a majority of our clients we acquire through marketing, right? Online advertising, how do we get the clients in is just seeing their profiles online and then getting them in that way. And we have a thing called suicide intelligence. So I'm going to show you a bit and piece of the suicide intelligence platform that we're building. So to understand my background, it will help you understand the Black Box Project. So I spent 11 years working counterterrorism and intelligence around the world. I was a Black Hat instructor for 4 separate times, so I understand cybersecurity at another level. I spent 9 years working digital forensics for child crimes. For a year, I worked for Homeland Security, watching child crime videos, doing digital forensics for it. And then I have a foundation called the Sentinel Foundation, where I've conducted 25 plus operations in 12 different countries, helping children that are being sex trafficked. I just got back 10 days ago from Gaza of getting Americans out. So we're very good at solving complex problems with innovation and data. So Black Box history, how did we start? How did we come up with this idea and the concept? So back in 2019, the CEO over at Stop Soldier Suicide, Chris Ford, called me up and said, hey, I got your number. I want to figure out how we can use data innovation to solve the suicide problem. And for me, it hit home personally. It's tough to say. It's like at 22 years old, I was writing eulogy for my best friend that killed himself after Iraq. I've had 5 friends since that date and time kill themselves. And it's a lasting effect on everyone that plays a part. So I was ready to jump at it any which way I could. And when I sat down with them and I started thinking through the problem set, I started looking back at all the people I've helped that were suicidal, my friends, and I realized one thing, that they were all posting the same thing on Facebook. They were all posting the same thing on Instagram of calling a buddy and helping a buddy. So they were projecting outwards of their needing help, and it really opened my eyes of, hey, there's something here. If this guy is suicidal, I know, and he's posting these memes online, then there's something that's not true in that data. And so I realized quickly, and Elon Musk said it's your cell phone is your 5th limb, and we're leaving all of these devices behind. And if you understand from a security perspective that these devices, in a matter of 6 months to a year, 2 years, we have a wealth of knowledge that we can actually get into. Now, your phone right now is hard to get into, but in 6 months it's not. In 12 months it's even easier. And so it's a time, space, and distance with security that we had. And so we had to figure out. So I proposed the idea of let's just look at the last second, the last year of life to find out. And that's where we came up with the black box project. If we were still trying to solve aviation problems without having a black box, we would not be anywhere we are in the aviation field that we are right now, right? And so we had to see what was going on and what was happening so we could then prevent and predict it later on in line. And so, I thought, this is a great idea. We can go through it. Now, the hardest part was acquiring these devices. And so I spent the next 6 months, COVID happened, and we said, let's just bootstrap this thing, whatever we need to do. I was like, I'll come over, we'll build through all the old equipment we have. We started piecing it together. And I just needed the missing piece was the family members. And so we started reaching out to our community, and I started meeting with them. And if you ever dealt with a suicide situation, you go into a household, the mother's suicidal, the father's suicidal, it's a generational impact from this act that happens. But they want to help, they want to give back. And so they had these devices, and I became friends with them. You can see from these 2 pictures, I go on fishing trips with them, I go golfing with them. We became a family, their first original 5 individuals. And so we started looking through it. So once we had the devices, and as of today, we have 78 different cell phones from 68 different families. We have laptops, hard drives, and tablets that will be later down the line. Right now, we're currently focused on the cell phones. And you can see to the left is during COVID, we just built this makeshift forensic lab with old equipment we had, and now you can see on the right, we have a government-level equivalent with Cellbrite donating all the software that we needed for free. We have magnet forensics. And so once we had that, we were missing the one piece, right? We know our strengths and our weaknesses, and we know we needed a team that was machine learning based and the best in the world. And I was on a call with Amazon just for fundraising, and we told them a little bit about Black Box, and that was the turning point for this whole project. Amazon, I had 10 other people tell me no, they don't want to be a part of this project. Amazon said it's one of the most innovative ideas they've seen. They would love to take any part of it, and it validated everything that we thought we knew and we had. And so we spent the first few months going through all these different cell phones, and we started seeing trends that this was a spur of the moment act. There was no data to prove that it was a spur of the moment. Well, I recovered a deleted suicide note 3 months prior, threw that theory right out. We saw that 5 of the 7 clients that we originally got in all went to the VA that day. So it's not only about preventing and predicting, but it's also accountability of what we're seeing through this data. And so by partnering with Amazon, we then roadmapped for the project. And so let's look at what we learned. So when I first started looking at this problem set, I had to think of myself. And I know when I'm hungry, I'm irritable. And the only way you can tell on a cell phone if I'm irritable is probably my text messaging to you. And so we said, okay, let's do sentiment and emotion algorithms or analysis over their cell phones, and let's look at all outgoing messages and try to identify what a good day is and what a bad day is. And then once we have the good day and the bad day, then we can narrow down and say, what were they doing on said day? So we were trying to find them in the mess. When we first started, we're trying to get better at targeting individuals to get them into the wellness center. And so we started looking through it. And so, majority you're familiar with this. We had to look at positive, negative, neutral, and then we had to look at anger, disgust, fear, joy, neutral, sadness, and surprise. And this is what we came up with. So we have our dashboard that we originally built here, and you can see the red to the green on the screen. And as they get closer, fear and anger, you can automatically see gets higher and higher. And so we were looking at these spikes, and I want to know what they're doing on a good day also, because What activities were they at? Could we target them over there? We need to know these patterns, and then on the bad days of how do we target them. And so we rank them by numbers and scores and go through. And real quick, we realized that the military community is not the easiest community to analyze sentiment or emotion because we probably curse every 15 seconds. I'm going to try not to do this presentation. Amazon asked me not to. But so we used Comprehend. we used the commercial off the shelf, and we realized real quickly we had to create our own. And so that's what we went through and we started to do and with it. So after that, after we created our own sentiment and emotion algorithm using Amazon, I almost said Microsoft, Amazon Comprehend, we had to look at semantic search of, so if I'm looking at somebody, if you're not familiar with it, I want to know if somebody's an alcoholic. I need to know if they're going out partying, I need to know if they're drinking, so I need to know every one of these different phrases. And so we go through here, we went through the chats, messages, and then we put in, I am in pain, I want to kill myself, I hate myself, I need help, so they're reaching out for help. And then I want to get wasted, on financial help. So by putting these sentences in there, it's going to get everything along those lines. And that way, when we're going through it manually, we could then go down narrative. How were they feeling? Could we really understand a lot about that individual? You can see it here. These are live results from it. So we put our input in. We upload through the S3 process that we all set up. We get the output, and we can start narrowing down on the phone, because if you're not familiar, it's a massive amount of data when you dump a cell phone. I have everything from your health data, your outgoing messages, your social media contacts, and so this is at that point in the project of really trying to understand this data set. Because forensic tools were meant to categorize data for courts of law. They weren't meant to profile individuals based on their behaviors. Right? It's just like Amazon knows exactly what I want to buy from their store. That's why they take all my money, is because they're really good at advertising to me what I want and who I am. So we parse through, the results you're seeing are only from 13 devices. We have about 58, so out of the original 19, 13 we could get into, and we had quality data. Now we're up to about 58 cell phones. Those results are still processing, we're still going through it. But you can see that, there's veterans that when I was reading through the messages, and now the software brought it out, was sponsor did not take them to the VA, killed himself. We had them that they went to the clinic, didn't get the help they need, killed themselves. We had their financial situation, they go through a divorce, killed themselves. And we know this data already. We all know that these major acts happen. You have a very short window if somebody is on that brink, but now we have the data to back it up and show it. After that, we had to know there's a lot of talk about sleep deprivation. But if you kill yourself, they're going to ask your wife, they're going to ask your husband, they're going to ask your significant other, they're going to ask your family member of how well were they sleeping. And you're going to say, I don't know. I really don't. Well, with our phone being our fifth limb, we knew that our phone could be that missing piece. And so we looked at message ranges, and we wanted to find between midnight and 4 a.m. and tried to identify of what they were doing, how active. So we created our own sleep analysis algorithm. We looked at message ranges, social media posts, Bluetooth devices connected, phone charging, health data steps, and came up with this comprehensive sleep algorithm. And we see that majority of all of our clients from this, or service members that we've studied, sleep deprivation is up here. We see that anger, fear is up here. Isolation, frequency of text messages, spiking upward. And so now we have the data to prove it. And so that's what we did. We went and we combined sleep, sentiment, isolation, and emotion trends all together, as you can see the diagram here, and then kicked out the probability mathematically of were they sleep deprived, isolation, fear, and anger, and they're all showing the upward trend. So you can see here, their start time increases, so when they go, how long they stay asleep. Because the first thing most people do is they pick their cell phone up after they wake up. They want to check their messages, especially if they're in a depressed area, they're looking on their Instagram, they're scrolling so they can get that dopamine fixed. So we can actually see this. And so where are we going? So we have all this data, and we have an understanding of what is happening, but what are we going to do about it? It takes great minds and people to come together. We know our limits. And I challenge everyone in the room to think you could be a part of this project to reach out to us. There's so many in this room that could be that missing piece that we need. But what we're doing right now is we're incorporating what our learnings into our call center. All right, so we're looking at our sentiment motion algorithms. When we have clients call in, we're monitoring our wellness coordinators, and we're also monitoring our clients to make sure that they're both trending positively. So if you call in, I can understand if you're having a bad day, but does it trend positive after our wellness coordinator is communicating with you? And we're using Amazon Contact Lens for that initial project that we're doing. The second part is creating an SDK. So if you have an app out there, and we could partner with you and give you our SDK that will run across your back to say that your clients are potentially suicidal, and here's why. And then our other goal is to create our own app called the Roger app, and it's a resource app for our clients so we can monitor them in real time and see them. And we know you have to call them up and say, hey, they're hitting these thresholds, maybe all from a gym membership. Call them up, check on them. The littlest things like that could really change a person to not commit the act. This for Amazon, I mean, this project would not exist without them. You know, they, like I said in the beginning, when they validated our hypothesis, this is where it took us to the next level. So we're the first two-time winner for the Imagine grant winners. And then I have to thank our partners we have in there. So Amazon Nonprofit, AWS, Amazon Regular. I mean, I think I've dealt with all of Amazon at this point, and I love it. I challenge any one of you that are thinking about using ProServe to use them. I have to give a big shout out to Sweta, the program manager, and TJ Gallagher. They were critical in the success of this project. You have Celebrate and Magnet Forensics donating it for free. You know, these are hundreds of thousands of dollars of software donated for free. Augusta Digital and Pura Vida Solutions are partners in creating the processing of this data. So that being said, I'll turn it over to Vina right now. I thank you so much for being a part of this and taking the time. I know we're the last session. Everyone's ready to go party in Vegas, so thank you so much.
Hi again. So we just heard two incredible stories from two amazing customers, and I just want to revisit their use cases real quick so we can kind of bridge to how you can apply this to your own organization. So first off, PBS. PBS had a need to consolidate and bring together a bunch of different data sources to gain insights, to build their recommendation engine using personalized, to explore generative AI use cases, all kinds of things. And this is something that comes up with pretty much every single one of my customers. So to give you a quick example, let's say that you're trying to gauge the effectiveness of a program that you're running. So you might have a data source that includes all the details about that program, demographic information from the people who are actually participating in your program. That's all sitting in one source. Then you might have another tool, maybe a survey tool. This is super common. You might have a completely separate tool that gets information from people who actually participate in your program and tell you how they're experiencing it. So if those data sets sit in two different places, it can be really hard to get insights and understand what about your program is working for people, what about it is not, which demographic groups are you targeting effectively, and what could you be doing better. But marrying these data sets can be difficult. And so that's where we enter the concept of a data lake house. So Hanif mentioned this a couple of times. Really, a data lake house is a data lake is a place for you to centralize your data regardless of the source, the format, the schema. It's meant to be a very, very flexible set of storage so that you don't need to know everything that you're going to do with that data on day one to be able to put it into a data lake and get some use out of it in 10 years even. So PBS use a couple different services to build their data lake. They use Amazon S3. So if you're not familiar with Amazon S3, it's simple storage service. You can think of it as just it's object storage. You can put pretty much anything in there, any format from any source, and it grows with you, very flexible and very scalable. But it's not quite as simple as just dropping all of your data into S3. So Hanif mentioned governance and permissions, and PBS is using AWS Lake Formation, which you can see on the right, as their mechanism for handling permissioning to the data sets, governance holistically, and then sharing the data sets between different members of their organization. And now let's revisit Stop Soldier Suicide. So you just heard Glenn talk about how important it was for the Black Box project to be able to analyze sentiment from text messages. So you might not have text messages in your own organization, but you might have similar unstructured texts. So think legal documents, social media posts, blog posts, really anything that you might put in natural language into a PDF or a Word document. So if you've got anything like that and you think it might be useful to get some information out of it, you can put that into Amazon Comprehend and it'll automatically pull insights from that text. So Glenn specifically mentioned sentiment analysis, which is available out of the box in Amazon Comprehend, but it can do a lot more than that. So it can pull out people, places, company names, key phrases. It can identify the syntax of different words. It can pull out the language. So it can do a whole lot, and it's very simple to use. You just input your documents, and you get out whatever you need. Another service that was really important for Stop Soldier Suicide was Amazon SageMaker Studio. So SageMaker is an end-to-end machine learning platform that is very, very flexible. You can build whatever you want on it. So you just heard me talk about Comprehend. That's an example of one of our machine learning services that's purpose-built for a very specific use case. So analyzing unstructured text and pulling information out of it. We have lots of tools that are similar to that in that it can do really specific things. So we have Amazon Poly for text-to-speech. We have Transcribe for speech-to-text. We've got Amazon Personalize for personalization, Forecast for forecasting. The list goes on and on and on. But not every one of your use cases is going to fit neatly into one of those AI services. So for example, analyzing sleep schedules, we don't have a service for that. So that's why Glenn and his team decided to use Amazon SageMaker. It's much more flexible. You can build your own algorithms. You can build your own models. You can import third-party models. Really, it's a tool where you can do anything machine learning. Now, PBS and Stop Soldier Suicide picked those tools because they were the right one for the job. So I am not telling you that you should be using all those services in your organization. It might be a really bad idea. So you don't need to force your organization to adopt any single one of these services. Rather, you should be picking the right tools for the job. So there's lots of different options here. We have just gone over a couple of services, but there's many, many more, and you can come speak to us if you want to figure out which services are most applicable for your use cases. So let's zoom out and look at the whole data lifecycle from start to finish. To get the most value from your data, you want to be able to securely ingest and store that in AWS, ideally in a data lake. Then you might have to do some amount of transformation or processing on that data to get it into a state where it's actually usable. Then you might want to perform some type of analysis, visualization, then maybe apply some artificial intelligence or machine learning. And then lastly, you might want to share that data within or outside of your organization to be able to, democratize that data that you already have. So this is just, block diagram, but let's see what this could translate to in AWS services. So keep these 6 boxes in mind. So this is just a high-level overview of how a typical data pipeline could function in AWS. So I do not expect you to know all these services. I don't expect you to remember all these services at the end of this session. Rather, this is just meant to be an example of a pipeline, and we're going to build through this pipeline step by step. So we're going to start from the ingest and go all the way to share. So just get an idea for the breadth of services that you have available to you. So to illustrate this better, I want to use an example, and we're going to follow this example as we're building out our pipeline. And we've mostly been focused on nonprofits here, so let's say that the goal is to convert 5 one-time donors into monthly givers. So keep this in mind as we're going through the pipeline. We're going to use it to tell the story. So the first step is to ingest data into AWS. So we have loads of different options on how to do that. You can see 9 that are listed on here. This is a non-exhaustive list. So our use case is we're trying to convert people into regular donors. So let's say that we've got maybe 2 data sources we think is going to be really helpful for that. So the first data source is a donor management system, or a DMS. You might be using something like Blackbaud or Salesforce to hold all the information about your donors. So to pull that into AWS, you can use a service called Amazon AppFlow, which you can see in the bottom left-hand corner. So AppFlow is a service that manages the SaaS connectors between lots of different platforms and AWS. So there, Salesforce, done. One of our sources already handled. Now, the next maybe source that we want to ingest to answer our question is, let's say that we've got an events platform. We've built it ourselves. It's sitting on premises, and this includes all the information about who is attending our volunteering events, our fundraisers, our galas, et cetera. So let's say, like I said, we built this ourselves, sitting on-prem, and the data for that is getting stored in a SQL server sitting on premises. So we're not going to use Amazon AppFlow for that. It's not meant for that. So instead, we're going to use a different service, AWS Database Migration Service, which you can see in the top right-hand corner. So DMS will help us either migrate the whole database into AWS if we want to just move the whole thing and work from there, or it can perform ongoing replication between your on-premises database and AWS. So there we go. There's our 2 data sources already handled. But let's just try a few more on for size. So let's say that you've got a website and you want to be able to gather clickstream data from that website, maybe give you more information about what people are actually clicking on. So if you want to stream that data into AWS, you can use something from the Amazon Kinesis family, which you can see in the middle. And then let's say that you wanted to acquire maybe a third-party data set, maybe something from census information or address information. So you can acquire third-party data sets through AWS Data Exchange, where you can see in the bottom right-hand corner. That has over 3,500 different third-party data sets that you can purchase, sometimes even for free. So once we've ingested data into AWS, we have to store it somewhere. And we're going to start moving a little bit more quickly throughout these different stages now. So you've ingested, where to put it. So we're going to put that in Amazon S3. So we talked about S3 a little bit. This is really going to be the foundation of our data lake. And you'll notice that I've got Redshift listed up here as well. So Amazon Redshift is our data warehousing service. But our question that we're trying to answer is actually pretty simple. We only need 2 data sets for it. Let's just say they're relatively small. We're not doing large-scale, massive analytics here. So let's just say Redshift overkill for now. We're going to stick with S3, ingest into S3. And if we want, we can always add Redshift on later. So we're keeping things very flexible by using S3 as our starting point. So now that we've got our data properly stored, we need to process it, transform it in some way to get it into a state where it's very usable. So unless you're extremely lucky, most of your data sets, as is, are not in a place where they can be used super cleanly. So an example of that would be, let's say that you've got your donor management system sitting in Salesforce. You might not have every single value about every single one of your donors filled in. You might have lots of null values, not applicables, et cetera. So that can be kind of messy if you're trying to run queries on data that looks like that. So you can use a service called AWS Glue ETL, which is extract, transform, and load, to get that data processed and into a form where it's going to be usable. And then next up, you can store all of your metadata in the AWS Glue data catalog. If you're familiar with the Apache Hive metastore, it's compatible with that very similar concept. But really, this is where you're storing the location of your specific data, so like the path to the files in S3. It also includes information about the schema and the format. And the purpose of this is for a querying engine to be able to know how to work with your data. So it's going to consult the data catalog to know where is your data set, first of all, and then how do I actually treat it. So that brings us to querying engines. So analyze and visualize. So we've got our data stored, we've got it cleaned, and now we want to be able to do something with it. And this is really where we get to the juicy part, and we're going to get our question answered. We're going to figure out which one of our donors are most likely to convert. So in our case, we're going to use Amazon Athena, which is a perfect example of a service that consults the Glue data catalog. So Amazon Athena is a serverless SQL querying engine. It sits right on top of Amazon S3. So you'll notice I did not say that you had to put all of your data into a specific database to run queries on top of it. Athena can kind of layer right on top. So this is where we're going to answer our question. We're going to use Athena to consult our 2 data sources, the events platform and the donor database, and we're going to figure out who's most likely to convert. So maybe we can kind of hypothesize that somebody who donated over $100 this past year and attended one of our events in the last month is most likely to convert. Maybe we're just thinking they're most likely to want to connect with us a little bit more. So boom, question answered. We solved our problem. But since that went so well, let's try to do a little bit more with it. So that brings us to predict and share, where we can start to apply machine learning techniques. So we already talked about a few different machine learning tools that you can use for your use cases. We talked about comprehend, mentioned personalize for recommendation engines. You guys have probably heard a whole lot about Bedrock and Q. So lots of different AWS AI/ML services that you can apply. But let's say for our use case, we have a non-technical user in our organization who wants to be able to ask questions about our data in natural language to get answers. So they don't know how to write in SQL, very common. They can use Amazon QuickSight or possibly Amazon Q to be able to get that question answered without having to know a bunch of SQL. And then let's say that since things are going so well in your organization, everybody is so impressed with all the work that you've been doing, you might have another team in your org that wants to be able to get these data sets shared to them so they can start doing stuff too. You can use Amazon Data Zone to share that data with the rest of your teammates. So that brings us back to the beginning. We're back at our original pipeline. We just fleshed it all out. This is meant to be extremely flexible. You should be picking and choosing the services that make sense for your use case. And if business requirements change, you can go back and adjust. So the purpose of putting things into a data lake is so that you're going to have a very flexible starting point, which makes the downstream stuff way easier as things change and you grow and your use cases evolve. So you're going to find that probably the first time you go through this process might take a little while. You might be trying to figure out which services you should be using or how to use them. But as you go through this a couple times, you're going to come up with new questions to ask. You're going to be ingesting more data sources as you go. And before you know it, you have become a data-driven organization. So now that we've hopefully gotten the gears turning a little bit, how do you actually get started? You might want to have a cool story to talk about at reInvent a year from now on stage. No problem. I got 5 steps for you. So bullet number 1 is really the most important. Pick an important but not urgent business problem to tackle. So you want to be asking your organization a question that's actually attainable for you to answer. This shouldn't require a million different data sources to answer. You want to set a goal that's reasonable so that you can get a quick win. That way, when you get to the urgent business critical stuff, you've already gone through this process a few times and you're familiar with the tooling. So really, the technology comes second. You want to pick a good question. That's the most important thing. Next up is determine what data you need to answer this question. So in our case, we needed Salesforce or that homegrown events platform, but you might have different sources that you need to be able to answer your question. So figure out what those sources are and incrementally populate your data lake. You don't need to bring everything in all at once. Next up, run analytics. So in our case, this was a really simple SQL query, but you can imagine that this could be using an AI tool, something cool with machine learning, whatever it is, maybe building out a business intelligence dashboard, run analytics to actually get you an answer to your question. Next up, take action based on those insights. So in our case, we think that we've got 5 people who are most likely to convert to become monthly donors, but we don't really know. So maybe we could track those people over time and test our hypothesis, or maybe we can nudge them a little bit and send them a personalized text message to see if they want to come back. Last step is measure against your original goal. So did you actually accomplish what you set out to accomplish? If you did, that's awesome. But if you didn't, that's actually okay, because this is an opportunity to adjust, try different things out until you solve the problem you came to solve. So this is not meant to be a one-and-done transformation. This is going to be an iterative approach, and being okay with that will help you build momentum and set goals for yourself that actually feel realistic and attainable. So start small, but think big, because this stuff is really cool. So we have loads of tactical support that we can provide you with as you're getting started on this journey. So you may already have access to your account manager and solutions architect that can help you build an architecture diagram that looks kind of like the one we saw before. We can do demos of services, help you build proof of concepts. All that stuff is already available to you. We also can provide you with more strategic support. So if you want to get a sense for where you are in that maturity model that Hanif showed, we can do something like that. We can help you build a roadmap going forward that focuses on your business needs over the next few years. So we can provide all kinds of different support, but really all this happens when you come and speak with us. So you guys already did the hard thing. You bought a ticket to reInvent. You flew all the way here. You've been in Vegas for 4, sometimes even 5 days. You sat through this session. So the best way to make this worth your time is to come speak with us and start a dialogue with your rep at AWS. And on that note, here is our contact information. We're all going to stick around for a little bit to answer questions. If you don't know who your AWS account manager is and you want to get in touch, you can use this QR code to get contact information for that individual. And yeah, thank you all very much for joining. And thanks so much to my co-presenters.